Before I can explain how to add, subtract, multiply, and divide these numbers, I want to make sure you're able to identify the sign of each number. So if we look at these three numbers up here on the screen, there's 3, 8, and a 6, and each of them has a sign to the left of them. The 3 doesn't necessarily have a sign written, but whenever you see a number without a sign, you assume that it is positive, which it is. If we look at the 8 and we identify its sign, the sign of that 8 is positive, and for the 6, to the left of it, there's a minus sign. So we say that that 6 is negative. Now if we look at this list of numbers below, notice that all of the 3's that are listed here are positive, even if they don't have a sign to the left of it. All of the 8's are also positive just because they have a plus sign to the left of it. And all of the 6's are also negative. That means that all of these expressions are equivalent. They're exactly the same. If you were to plug any one of these expressions into the calculator, you'll get the exact same thing out of it. And the reason for that is that these numbers have the same sign. Their signs are consistent throughout each one of these expressions. So now that we can identify a number sign, we should be able to add and subtract and multiply and divide these numbers just by following these two sets of rules. So adding and subtracting positive and negative numbers is different than multiplying and dividing. When we add and subtract integers or positive and negative numbers, we always want to look at the signs of each number. So we want to look at whether they're positive or negative. If they have the same sign, then we're going to add the numbers together. If they have different signs, if one of them is positive and the other one's negative, then we're going to subtract the numbers. But in the end, after we add or subtract those numbers, the final answer is always going to have the sign of the larger value. So let's go ahead and do some practice problems. So for this first problem, we have 4 minus 12. If we identify the signs, the 4 is positive, the 12 is negative. That means they have different signs, so we're going to subtract the numbers. And by that I mean I'm going to ignore the fact that the 12 is negative. I'm going to take the larger number and subtract the smaller one. So 12 minus 4 is 8, so I can write an 8 down. But the result needs to have the sign of the larger value. Between the 4 and the 12, the higher value was the 12, ignoring the negative sign. And the 12 is negative, so my answer has to be negative. So my answer is negative 8 for this problem. For the second problem, we have negative 2 plus 5. The 2 is negative, the 5 is positive, so they have different signs again. That means we're going to subtract the numbers. So 5 minus 2, and again, I'm always choosing the larger value, ignoring the negative signs. 5 minus 2 gives me 3. But since I'm adding and subtracting, the result needs to have the sign of the larger value. The larger value is the 5, and the 5 is positive because there's a plus sign to the left of it. That means my answer is also going to be positive. So I don't need to write a plus 3. I can just leave it as 3, positive 3. For the next problem, we have negative 8 minus 4. The 8 is negative, the 4 is also negative. That means that they have the same signs, which means we add the numbers together. So ignoring these negative signs, 8 plus 4 would give us 12. But if I move on to that last step, the result always has the sign of the larger value. The larger value is the 8, and the 8 is negative, so my answer is negative 12. For the next problem, we have a positive 10 and a negative 1, so they have different signs, which means we're subtracting those numbers. So if we do 10 minus 1, we get positive 9. The larger value is the 10, and the 10 is positive, so we're left with just 9. For the last example, for adding and subtracting, we have negative 6 plus 3. The 6 is negative, the 3 is positive, so they have different signs, which means we're subtracting the numbers. So 6 minus 3 gives me a 3. But again, the result always has a sign of the larger value. The larger value was the 6, and the 6 is negative, so my answer is negative 3. So that's adding and subtracting integers. The only thing similar with multiplying and dividing compared to adding and subtracting is that we're still looking at the signs. We're still looking at whether the signs of the numbers are the same or if they're different. If they have the same sign, then our answer is going to be positive. If the two numbers have different signs, if one's positive, one's negative, or the other way around, then the result is going to be negative. Notice that there's no last step on here. So for adding and subtracting, the result always had the sign of the larger value. But for multiplying and dividing, the larger value does not matter. If they have the same signs, the answer is just going to be positive. If they have different signs, the result's going to be negative. So jumping into the examples, for this first one, we have 4 times negative 3. They have different signs because the 4 is positive, the 3 is negative, so the result is going to be negative. Now we just do the multiplication. 4 times 3 is 12, so the result is negative 12 because they had different signs. For the second problem, I do want to point out that these numbers are being multiplied whenever you have two numbers in parentheses right next to each other. Even if there's no multiplication symbol, that does mean that the parentheses tells us that they're being multiplied. So if we look at the signs of each number, the 2 is negative, the 5 is negative. That means they have the same sign. So the result is going to be positive. So 2 times 5 gives me 10. And because they had the same sign, a negative times a negative, we end up getting a positive answer. For the next example, we have a negative 8 and a positive 2, and they're being divided. So they have different signs, which means that the result is going to be negative. So 8 divided by 2 is 4, but the result needs to be negative, so it's negative 4. For this next problem, we have a negative 12 and a negative 4. So they have the same sign, they're both negative. That means my answer is going to be positive. So 12 divided by 4 gives me a positive 3, and we're done with the problem. For this last example, we have positive 9 and a negative 3. One's positive, one's negative, so they have different signs, which means the result is going to be negative. 9 divided by negative 3, or 9 divided by 3 would be 3, but the result needs to be negative, so we end up getting a negative 3 as the final answer. Following these two rules should be enough to complete most of the problems that you come across, but there are some special cases in which these are a little harder to follow. Sometimes you'll come across weird looking problems where you have multiple signs right next to each other. Anytime you have an expression where there's two negative or two minus signs next to each other, you want to replace both signs with a single plus sign. For this example here, we have 4 minus negative 2. So we have two of those minus symbols next to each other. We're going to rewrite this expression. We still have a 4 and a 2, but instead of two minus signs or two negative signs, we're going to replace it with a single plus sign. So now this becomes 4 plus 2, and we can ignore the original expression. This is our new problem, and 4 plus 2 would just be 6. So originally it looked a little confusing. We had this expression, but anytime you have two minus signs next to each other, you change it to a plus sign, and you go from there. For the second one, if we look at this expression, we have negative 3 minus negative 6. Even though the negative 6 is in parentheses, if you were to ignore those parentheses, you would see that there's two minus signs somewhat next to each other. There's no numbers in between them. Because that happens, we can replace both of those signs with a single plus sign. So this is actually going to become negative 3. And again, this first one, this first negative, that's part of the 3, so we're going to leave that alone. So it's going to become negative 3, and instead of these two negative signs, we're going to replace it with a plus. Then we have a 6 afterwards. So this is my new problem, and now I just need to follow the rules that I had mentioned earlier. So these two have different signs, which means we're going to subtract the two numbers. So 6 minus 3, and that would be a 3. Because we're adding or subtracting, we want to look at the larger value. The larger value is the 6, and the 6 is positive, so our answer needs to be positive. So it would be left alone. Our answer would be just positive 3. For this next example, the same type of thing happens. We have two negative signs next to each other, so we can rewrite it. We still have a 2 and we still have a 3, but instead of those two minus signs, we replace it with a plus, and we get 2 plus 3, which is 5. For this last example, we have negative 8 minus 2. Now, if we look at the two minus or negative signs, they are not directly next to each other. So we're not going to turn these into plus signs because there's no two negative or minus signs right next to each other. They're separated by a number. So this is kind of a trick example. We cannot rewrite this. We would just leave it alone. But if we actually work it out, the 8's negative, the 2 is negative. So they have the same signs, which means we're going to add the numbers together. The answer is going to be a 10, but if we look for the larger of the two values, that's the 8, and the 8 is negative, so the answer is negative 10. So again, that was kind of a trick example, but the point of it is these two negative signs are not directly next to each other, so we don't replace them with the plus sign. So when a plus sign and a negative sign are directly next to each other, you can erase or delete the plus sign, leaving the minus sign alone. So for this example, we have 6 plus negative 1. And while you probably won't see it written in this exact way, anytime you have a plus and a minus sign, you can ignore the plus sign. So we're literally going to ignore that plus sign. We're going to treat this as 6 minus 1, and the answer would be 5. So 5 is the answer to this original problem. For this next example, we're going to do the same thing. We have negative 5 plus negative 2. So we have a plus directly next to a minus sign. When that happens, we can ignore the plus sign and leave that negative sign alone, or the minus sign alone. So this expression will become negative 5. I'm going to forget that plus sign, minus 2. Now I am going to ignore the parentheses too. So we have negative 5 minus 2, and we can treat this as our new problem. If we look at the two signs, they're the same, they're both negative. So when they have the same sign, we're going to add the numbers together. We get a 7. If we look at the larger number is a 5, and the 5 is negative, so the answer is negative 7. For the next problem, you see the same type of thing happen. There's a plus and a minus sign next to each other. It is separated by the parentheses, so I'm going to ignore the parentheses. And this will leave me with the expression negative 1. And because there's a plus and minus sign, we're going to ignore the plus sign, minus 8. So we have negative 1 minus 8. They're both negatives, so they have the same sign, which means we add the numbers together and we get a 9. The larger of the two values is the 8, and the 8 is negative, so my answer is negative 9. And this last example is 7 minus positive 3. Most likely you're never going to see any expression written down this way, but I suppose it is possible. The point of this is there's a plus next to a minus sign. The order is reversed compared to the others where it's a plus and a minus. This one's a minus and a plus. But the idea is exactly the same. These two things are next to each other, so I'm going to ignore that plus sign and the parentheses. So I'm going to rewrite the expression as 7 minus 3. And this gives me the answer of 4. So before I end the video, I do want to go over this notion that two negatives make a positive. That quote is pretty misleading. It's probably what a lot of people remember, but it only applies to multiplication and division. So I would recommend that you forget about that idea. And here's an example that kind of contradicts what this statement is saying. If you have negative 4 plus negative 4, the answer is not positive 8. Because they're being added or subtracted, depending on how you look at it, these follow the first set of rules that I listed earlier in the lesson, where if they have the same signs, we add the numbers together. These two 4s have the same sign, they're both negative, so we do add them together and we do get an 8. But we need to look at the larger of the two values. Now in this case, they're both exactly the same, so it doesn't matter which one we look at. The answer is going to be negative. So the answer to this problem is negative 8. So we have two negatives and they end up making a negative. They do not make a positive. So just forget about that. It's going to give you some wrong answers down the line. So hopefully you found this useful. These explanations are a little different than what you would find in a textbook or from other professors. So feel free to look up other people's videos or tutorials on working with integers.